Hi, this is Samata. Well, me and my friends Nivedita, Nitya and Karthik from GRIET Biotech Department have done project on in silico study of DNA topoisomerase 1 inhibitor topotecan for brain cancer. The main objective of our project is to design a new drug with the help of bioinformatic tools. So, what is bioinformatics? It is a combination of biology and information technology. And why bioinformatics? Because it greatly reduces the time of design when compared to wet lab techniques and also cost effective, and accuracy is nearly 99%. So the main objective of our project is through rational based drug design approach we design new analogs by replacing pharmacophore groups in ligand. Well, so, what is a pharmacophore? Pharmacophore is an abstract description of molecular features which are necessary for molecular recognition of a ligand by a biological macromolecule. Then, docking is performed. Finally, binding free energies was calculated for each analog. The analog with R group having lowest binding free energy will have the maximum binding affinity. Hence, it is suitable as a best fit. For tasking this project, we used various softwares like Hyperchem for designing structure, SPDBV for identification of active sites, Discovery for energy minimization, Gold for docking. In our project, we have designed the drug topotecan. Well, topoisomerase 1 is required for DNA relaxing during critical cellular functions. Once topoisomerase 1 creates a single strand breaks, the DNA can rotate in front of the advancing replication fork. Topotecan intercalates between DNA bases. This intercalation disrupts the DNA duplication machinery when it reaches a site where topotecan is intercalated. This disruption prevents DNA replication and ultimately leads to cell death. In this drug designing process, we adopted several steps like calculation of single point. The result of a single point calculation gives the potential energy of the system at the geometry as well as the gradient at that point. In this drug designing process, we adopted several steps like: first step, designing the structure of topotecan in Hyperchem and minimization of energy. Step 2, changing of R group at pharmacophore site. Then R groups at pharmacophore site are replaced by some of the R groups like H, OH, NS3, F and so on. As to know the activity of drug in water, the drug is solvated in periodic box. Then geometry optimization of the drug after removal of water is done. The next important step we did is identification of active site using SPDBV software. We use discovery auxiliaries for protein energy minimization. And the final important step we performed is docking. It is a procedure to find the best fit between the pharmacophore site of drug and the active site of the protein. And finally, we have calculated binding free energies. And the final result we obtained was the analog with R group H is having lowest binding free energy and will have the maximum binding affinity. So we conclude that these results clearly indicate before synthesis and biochemical testing of new analogs, one can use molecular mechanic based methods for qualitative assessment of relative binding affinities for speeding up drug discovery process by eliminating less potent compounds from synthesis. Thank you.